The last section of this chapter covers what's called the natural logarithm. Now, when you're talking about the natural logarithm, what you have to think about is looking at this, which is going to be very similar to that compound interest formula that you looked at. What we're going to do is we're going to change the value of n so that it's increasingly larger. And what you should see happens is that it's 2.7, 2.71, 2.718, 2.712. This number, not exactly this one, as we get for larger and larger values of n, the value of this function gets closer and closer and closer to a value that we call e. When we start to undo e, it's what's called the natural logarithm. So just kind of a refresher, if we have something in exponential form, we can write it in logarithmic form like this, meaning log base 2 of 8 is 3, right? Here's another exponential form. Here we go. Now, so that when we look at it in this form, if x is equal to e to the 5, meaning this number approximately to the 5th power, we can undo that by saying the natural log of x is equal to 5. Natural log is the same as writing the log base e of x is equal to 5. And then the reverse is also true. If we have e to the power of x equals 7, then x is equal to the natural log of 7. Or again, we could think of it as log base e of 7 would be equal to x. What this next page shows really is just that the natural log and e to the power of something undo each other, so that when you're solving logarithmic equations involving e or involving the natural log, it's how you undo each thing. So again, if I think of this as the log base e of e to the 5th equals 5, if I rewrote that, I would say e to the 5th is equal to e to the 5th. The reverse of this is also true. If we have e to the power of natural log of 7, then e and natural log cancel, and 7 is just our answer. So let's do a couple of examples. If we have the natural log of e to the negative 2, you don't have to do this every time, but just so that I can demonstrate it for you, if you think of log base e of e to the negative 2 is equal to what? Well, e to that x power is e to the negative 2, so this is just equal to negative 2. If I have the natural log of 1, so that's like the log base e of 1 is equal to what? So e to what power is equal to 1? Well, that's going to be 0. Or if I have e to the natural log of 5, remember e and natural log cancel, and the answer is 5. So let's look at solving a couple of equations. I have the natural log of x is equal to 1/3. So what I can do is I can raise both sides of this equation to the power of e. So e to the natural log of x is equal to e to the 1/3 power. Well, e and natural log cancel, so x will be equal to e to the 1/3 power. Now once I get to this point, I can just put it directly into my calculator. Now when you put that into your calculator, you just push the second button and then natural log ln, because that's going to be e to the x. It'll open a parentheses for you, so you just put 1/3 into it, and we find that x is equal to approximately 1.396. The reverse is true when you've got an equation with a variable in the exponent. You just apply the natural log to both sides. Again, e and natural log cancel, and you get 3x is equal to the natural log of 27. Divide by 3 on both sides, and then you put this directly into your calculator. So when we put this into the calculator, we get that x is approximately equal to 1.099. Now remember when we were doing all that change of base rule, we had the log base a of b, and we could change it so that it was all in base 10, and we would say log of b over log of a. Well, we can actually do this with the natural log as well. So if we have log base a of b, we can make it natural log of b divided by natural log of a. This change of base rule works with any base. We could make this log base 3 or log base pi or whatever we wanted it to be. We choose base 10 because we can easily put into the calculator. For that same reason, we can also use the natural log because, again, it's easier to put into the calculator. The same thing will work also when you're solving equations. Normally we take the log of both sides. You can take the natural log of both sides of an equation as well. Again, we choose those values because we can enter them into our calculator the easiest.